let's take a look at classic encryption code, I suppose, called Rot1 or Rot1. The term comes from rotation. So what we do is when we're encoding our message, we're going to take the alphabet and then we're going to kind of rotate all of the letters forward one position. So what's going to happen is we're going to take our message, push it over, so that an A in the original message is a B in the coded one, and a B in the original one is a C in the other one. If we get a Z in the original message, it will become the letter A. So it's going to kind of wrap around this way. So here's what we need to do to set it up. I've got the scanner already set up for user input. We're going to need an original string that the user is going to want to encode. And then we are going to have the coded version, and we're going to construct this as we go. So this is going to be an example of an accumulator variable that we are going to construct as we process the original piece of text. So we'll also need a variable representing which letter we're going to be dealing with. So like A, considering the way that strings are stored, will have the position 0, Z will have 25. Then we are going to need the alphabet. So the Java doesn't by default know what the alphabet is. And even if it did, we would have to kind of specify how to use it. So we are going to define it for our purposes here so that our program will understand what is a letter versus what is not a letter. And for this program, we're going to assume that the user is going to enter all of the text in lowercase. So we'll prompt for message to encode. Enter the text to be encoded. And we'll store it in the original. So original gets the value of input dot next line. And then we're pretty much ready to start. When we're done, we're going to print the coded version. So in between here and here, we have to develop a message for encoding this text. So here's where we're going to start. We are going to traverse the original message. And then we're also going to change all letters to the next in the alphabet. Okay, so whenever we're doing a traversal, we're going to use a for loop. So for int I gets the value 0. We'll do this while I is less than the original dot length. So you can see by using less than, the calculator, the alphabet has a length of 26, but the last position is 25. So by putting a less than here, we know that it will not actually get to 26. It'll stop at 25. And then we'll do I++ here. Okay, so now there's an important distinction between what we do if something is a letter versus what we do to it if it's not a letter. So what we have to do is we have to check to see if it is a letter or not. So we need an if statement for that. And what we're going to check is we're going to check to see, say they enter the text, actually enter the text to be encoded. So the first thing that we would be looking for would be an E. So E would be in this position. But then when we get to the space, we don't want to change the space to a particular letter. So we have to have something to handle this. So we can do this by the knowledge that this is a character that is not in the alphabet. So let's choose index of. Index of is going to be our clue for this. So what we're going to do is we're going to check alphabet dot index of. And then what we're going to do is we're going to check for the particular letter that we're looking at. So the first time we go through the loop, we're at position 0. So the first thing I would be doing would be to check the E. Is the E in the alphabet? So I need a substring. I don't want to check the entire thing. I need a substring of one letter based on the letter I from our original text. So here's how it works. We want part of the original text. So it's original dot substring, because we want a part of the original text. Now, what part of it do we want? We want the letter that we're currently looking on. So that's I, comma, I plus 1. And what we want to do is we want to check to make sure that it's there. So if it's there, then this will give us any number other than -1. So we're going to do this while the position of whatever letter we told it to look for is not -1. Now, we'll do the easy part first. Otherwise, what we're going to do is we're simply going to add the character that we're on. So when we get to the space, if it'll find, oh, it's not a letter, so let's just add the space onto the final text. So coded plus equals, this is going to be the original dot substring I, comma, I plus 1. You know what? I don't need parentheses here because I'm not doing comparison. Okay, so what we're going to do is if it comes to a character that is not a letter, it's just going to slap it at the end. Now, here's a testing method that I like to use, is just to make sure that this is doing exactly what I want. I'm going to also print it every single iteration of the loop, and I'm going to remove this with a comment afterwards. So let's run the program. Oh, there is an error. Cannot find symbol. Original. It's very important always to spell your variable names correctly. Let's see if I got any more. Okay, so here's what I'm going to do is I'm going to put something with a whole bunch of punctuation in it. So I'm going to put J period T apostrophe R question mark G space U curly brace R curly brace. Okay, so let's see what our program does. So you can see what it does is the first time it goes through the loop, it adds nothing onto our string, and then because it skips over the J, and then because this isn't a letter, it puts a period, and then it doesn't add anything, so we still just have a period, and then it adds on the apostrophe. So you can see it constructs it one character at a time, and every time it comes up to something that is not a letter, it's just going to drop it into our final string. Now, what if it is a letter? So that's what we're going to handle here. So the first thing I want to do is I want to find out what is the letter. So what is the letter? And we're going to use our letter variable for this. So our letter is going to get the value of whatever position our letter is in this alphabet string. So because we're searching the alphabet string, we're going to put it as the root string, alphabet dot index of. Now, what is it that we're looking for the index of? So we're looking for the index of whatever letter from the original string we're currently looking at. So I'm going to do a copy and paste here. So this is going to find where this letter is in the alphabet. And it's always a letter because we've made this check to make sure that it's a letter. Now, if we end up with a situation where we have a Z, that's the only time in this process that we're going to want to do something different. So if the letter equals 25, so the letter in position 25, which is Z, then what we're going to do is we are going to slap on an A instead of the Z. Else, what we're going to do is we're going to add on a letter from our alphabet string. So whenever we're grabbing a letter from our alphabet string, we're going to go alphabet dot substring. So we don't want to slap the entire alphabet on there. We want to get a letter from it. And we're going to go from letter to letter plus 1, which is not quite right, but let's see what this one does. This will be kind of our test version. So we'll run this. So let's say we have our message, have a nice day. So you can see here what it's doing is one letter at a time. It is assembling our final text. Now, we didn't do this quite correctly because it's just taking the letter and then putting it into the place. We don't want the letter from the alphabet that we're looking at. We want the next letter of the alphabet. So if they gave us an H, then what we want to do is we don't want to look at H, we want to look at I. So what it's going to do is it's going to determine that we were looking at an H, and then I want it to put in the next letter. So the way we do that is we don't go from letter to letter plus 1, we go from letter plus 1 to letter plus 2. So let's run that again and see what we get. So the text to be encoded, let's go with have a nice day again. And now we get this encoded with all of the following letters in the alphabet. So just to finish off our program, we usually want to remove the test code that we put in there, and we'll run this again. And let's put in brush your teeth as the message there. And then we get the coded message that tells the user to brush their teeth.